Hello, AP Calculus world. So my son has these little foam rockets that he likes to launch off. He is almost 3, so he's very intrigued with them. Anyways, that inspired me to do a rocket launch problem. So here we go. We'll get right into it. A small rocket is launched vertically from the ground with a velocity given by v of t equals 60 minus 2t. Okay, so right off the bat, think about what t means. Time, right? Okay, so the amount of time the independent variable goes by, they tell you how fast it's going. Okay, the velocity. And remember that velocity also specifies direction. Okay, it tells you what direction it's going in. Positive, meaning it's going upward, and negative means it's going downward. Okay, where v of t is in meters per second and t is in seconds. Okay, so they tell you the units you're using. Make sure to include those as you go. Hey, find the time when the rocket reaches its maximum height. Let's do it. So just as a refresher, okay, there's s of t. That is the displacement function, okay? The derivative of that, v of t, okay, is the derivative, and that is the velocity function. And then a of t, oh, sorry about that. A of t is the acceleration function. So if you derive each of these, you will get the next function, okay? And then similarly, if you take the integral of each, you'll get the other one. The integral of a of t is v of t, and the integral of v of t is s of t, okay? So they go hand in hand with each other. So let's find that time. So what you should remember is that what is true about the rocket when it's at its maximum height. Where'd my rocket go? Oh, here it is. Think about the rocket going up, right? It goes up like this, hits up here. At its maximum height, how fast is it going? 0, right? 0 meters per second. Okay, and then it goes back down. What function do they give us? V of t equals 60 minus 2t. That's the velocity function, but we want the velocity to be 0, right? Okay, so here's what we do. All we have to do is say 60 minus 2t equals 0. And now we have a very simple algebra problem, okay? Calculus setup, but an algebra problem that we can solve pretty easily. We're just going to add our 2t from each side to each side. We get 2t, let's flip it around, equals 60. Divide each side by 2. And t is going to equal 30 seconds. Okay, so that's the first one. Next one, determine the maximum height of the rocket. All right, so think about this one. We're already pretty much there. Because what do we know so far? We know that it takes the rocket 30 seconds to get to its maximum height. Okay, we also know the velocity function. However, do we know any of the other functions? No, what can we find? Well, remember I said that we could go backwards and take the integral as we go from the velocity function to the displacement function. Okay, so let's do that. We're going to integrate, okay, and we're going to take an indefinite integral, which just means basically, you know, if we're starting from the ground level, right, we want to find in general, what is the displacement of the rocket from the ground going up? Okay, so let's take the integral of, sorry about that. Take the integral from, indefinite integral, 0 minus 2t dt. And you want to remember your reverse power rules, right? Okay, so the integral of a constant 60 is going to be 60t. The integral of negative 2t is going to give us negative 2t squared, okay? And remember, because we want to go t to the second power, right? And then we're going to divide that coefficient by the second power, which is 2. 2 divided by 2 gives us 1 as our coefficient, okay? So we have 60t minus t squared, and then we have a plus c. If you remember that from taking indefinite integrals, that c represents the constant, because if we have a constant of a function and we take the derivative of it, that constant's going to fall off. So when we go the other direction, you're going to see that a constant might show up again, okay? But I want you to remember something. What is the height at time equals 0 for this rocket? It's 0, right? So we actually know if we plug in 0 into this function, okay, 60 times 0 minus 0 squared plus, we don't know what our constant is yet, it should actually be at a height of 0, okay? We're going to get rid of this term, get rid of this term. That constant is 0, meaning we can actually just ignore it in this case. That won't always be true, but in this one, since the rocket is starting from the ground, that constant is going to be 0. Okay, so this is our displacement function. And now all we have to do is, you remember, like I was saying before, that this rocket is at maximum height when its speed hits 0, its velocity hits 0. That is at 30 seconds. So we're going to say S displacement of 30 equals 60 times 30 minus 30 squared, okay? And that comes from just plugging in time equals 30 seconds to t. That's going to give us 1800 minus 900, which is going to give us 900. And remember, units are important, meters, okay? Because everything here is in meters. So it takes, this rocket takes 30 seconds, gets to 900 meters into the sky, and then it's going to fall backwards. Now, think about this last question. Find the total time the rocket spends in the air before hitting the ground. You can actually answer this question without doing any more math and just some more logic, right? We're not taking into account anything like air resistance, okay, where it would actually affect the rocket. We're just assuming this rocket shoots up and then it goes right back down. And if it starts in the ground and it takes 30 seconds to get to the top, if you're desperate and don't remember how to do part C, how long do you think it's going to take to go back down to the ground? 60 seconds. That's your answer, right? However, let's show the map anyway. Okay, so here's what happens. Find the total time the rocket spends in the air before hitting the ground. So again, at ground level, okay, S of t equals 0. The original displacement, not how far the rocket traveled, but the original displacement would have to equal 0. So let's set this function equal to 0. If we go back to our displacement function, okay, S of t equals, it's this guy, 60t minus t squared. So we're going to say S of t equals 60t minus t squared, and we want to set that equal to 0. Okay, so then what I would recommend we do is take a look what is in common to both of the terms here. They both have t. So let's pull out a t. Okay, we're going to have 60. I'm sorry, t is pulled out. We divide that and get 60 minus, we divide this and we get t equals 0. Now we set either of those factors equal to 0. T equals 0. Well, that makes sense because that's where we started, right? At time equals 0, the height equals 0. Now let's set 60 minus t equal to 0. Some of you are like, why do we even have to write this? Well, it's good to know how to. Okay, t equals, and I flip it around because we like the variable on the left, t equals 60, meaning 60 seconds, okay, that it would take to go from the beginning to the top, back down, okay? So that's this rocket launch problem. You also can, graph this displacement function if you want to take a look at what this would look like. You could also graph the velocity function. That would be specifically a linear function. And all the fact that the velocity is linear, that just means that the velocity is constant. Well, I shouldn't use my rocket because that's not what the rocket's doing. The velocity of the rocket is continuously going down, okay? And that makes sense. It shoots up right away, but then gravity takes a hold, and gradually that velocity right here goes less and less and less. And if anyone was curious, the acceleration function, like I talked about up here, if we take the derivative of this, what are we going to get? The acceleration equals -2. What does that mean? With each second that goes by, the rocket is going to slow down by 2 meters per second. Okay. So it's kind of cool how all 3 of these functions go hand in hand. That's why motion is so great to study when you're learning calculus. I honestly don't think you should fear it. I think it's actually a very helpful tool to understand integrals and derivatives in a very conceptual way. So if you could just like this video or comment or let me know that you enjoyed it so I can make more of these. It's my goal, I'm recording this March 15th, 2025. AP exam is May 12th this year. So if we can help you get, college credit for calculus so you don't have to do it over again, I would be happy. So that's it. I will see you guys in the next one.